Hi guys, this is Shiliang from Group 9, Section 11. Today, we are going to talk about our electronic device and circuit group assignment 2. Topic is about BJT as amplifier. As you can see that, this is our circuit from the group assignment instruction. As you can see that, it's from figure 1. And this video, we are talking about how we use multisim to get the input impedance, output impedance, gain, and low cut-off frequency. Before start, I would like to show you all how we get the RC value at the collector. Here is the solution how we get the RC. As you can see that we use DC analysis and we use the Thevenin theorem to find the VTH and RTH. After that, we use KVL loop 1 to find IC and IE. After that, we go through loop 2 KVL to find our RC is 1.15 kilo ohm. So right now, I will show you all how we get the input impedance. At the first, double click on this wire. So we can get this wire name is 6. For this wire, we need to divide by the current of RS. So we can get the input impedance. As you can see that this is the graph. So when we drag the cursor to, we need to see for the Y2. The Y2 is 838.0904. Let us compare with our calculation. This is our calculation. As you can see that this is our Z-in input impedance. Based on our calculation, we get 0.863 kilo ohm. Compared to our multi-stim stimulation, we get 838.0904, which means it's a quite closer value. Now, I will show how we get the output impedance. In order to get our output impedance, we need to add one current source and we need to set it as 1 ampere in order to get our output impedance. As you can see that this is our graph and we need to use V out divided by I out, which means that our output impedance. So as you can see that I drag cursor to, so we need to see from the Y2. So our Y2 is 1.1366 kilo ohm. So let us compare with our calculation. As you can see that this is our Z out. Our Z out equals RC. From the DC analysis, we get our RC is 1.15 kilo ohm. Compared with the multi-stim stimulation, is very closer. So right now I will show you how we get the gain. So in order to get the gain, we need to use an oscilloscope. The A channel we need to connect to the input, B channel we need to connect to the output, and then both channel terminal negative we need to connect to the ground. So right now we can double click the oscilloscope. So as you can see that there's above a sinusoidal graph. The blue color shows that the output, and then for the red color shows the input. So we drag two cursors to the peak of both sinusoidal graph. So T2 minus T1 we can get negative 5.491 volt. So let us compare to our gain from the calculation. So as you can see that this is our AVS. We get our calculation is negative 5.5845. So which means it's quite similar to our simulation for multisim. So right now I will show you all how we get the low cutoff frequency. At the first, we need to select for the this wire beside the C2. So double click. We need to get the name for this wire. So the name is tree. Then we need to go through for the graph. So as you can see that this graph is our frequency response for our circuit. Then as we know that local frequency is determined at the -3 dB point relative to the maximum mid-band gain. So we need to find for the mid-band gain first, which is this straight line. So put our cursor at this anywhere of the straight line, and we can get that the mid-band gain is 14.7355. So right now, right click, we need to set our Y value to the left in order to find our local frequency. So for this 14.736, we need to minus 3. So we will get 11.736. So press OK. Then you will go through this side, and then we will get our X1 is 1.2477 kilohertz. So let us compare with our calculation. See that is our calculation. We found that our low cutoff frequency is 1.167 kilohertz. So which means it's quite similar to our result from multisim. So in this video, I already covered for the input impedance, output impedance, gain, and also the low cutoff frequency from the BJT circuit. That's all for group 9 from section 11. Thank you.